Listen. If your footsteps sound like that, then in this video I will help you transform them to this. And the reason why your footsteps suck is because your code sucks. So let's throw this shit out and write a clean and scalable dynamic footstep system for your game. And as always, before jumping onto the code, I will take some time first to explain to you the logic behind the system that we will be building today. Because once you understand the logic, the coding just becomes complementary. Here in this drawing, we have a grass surface with our player standing on top of it. Now each surface will have a unique identifier that will help us identify one surface from another. For the sake of simplicity, let us call this ID surface and have it refer to the name of the surface, that is in this case grass. Now for each of these unique identities, we will store in a separate map the corresponding footstep sound that we want to play whenever we step on that particular surface. Now the logic to actually play these sounds will be stored in a separate global object independent from any actor. So this way later on, not only the player but also other characters in your game can leverage this object to play their footsteps. Now to use this object, each player or character in your game will have a raycast pointing downwards. The job of this raycast is to detect the surface ID your character is standing on. Now your object will contain a function that will take a reference of this raycast whenever any character calls it. Using that, it will get the surface ID and then the corresponding sound mapped to that ID, and then finally just play it out. Now the question arises, when do we call this function? And this is kind of tedious. Now what you have to do is that you have to scrub through your player's running animation and run this function at the exact frame whenever the feet of the player is touching the ground. And yeah, that is pretty much it for the logic. Now let's code it out. First, let us set up our scene by adding the unique identifier to our three surfaces, which in my case is grass, metal and wood. For this, we will go to each of our surfaces mesh instance and add to it a metadata called surface of type string. This will store the surface's name, aka its unique identity. I will also create two new global objects, one to store the footsteps logic and the other an audio stream player to actually play the sound. Finally, I will also create a raycast as a child to our player. This raycast will point to the ground and will be responsible for detecting our surfaces. Now let us write the code to our footstep player logic. That is the separate node we created. Firstly, we will create a map that will map the surface IDs to the corresponding footstep sounds. Now next, we will create a function that will take in reference to the raycast, get the ID of the surface the raycast is colliding with, and then pass on the corresponding sound to our audio stream player. Inside the audio stream player, we will just play the particular sound we receive. To initiate this flow, we will make a driver function in our player script that will call the footstep objects function by giving in the reference of its raycast. Now to actually play the footstep sound, I just go to my player's running animation and add in the driver functions call on every frame the foot is on the ground. And with this, we are done. Now let us demo the code out. As you can see, our code now not only looks beautiful, but sounds too beautiful as well, with the code being scalable, more clean and way more manageable than the previous iteration. And so yeah, that is it for today's video. Hope you guys liked it. Don't forget to like and subscribe and comment to boost the algorithm. And I will catch you guys the next time. Okay, bye.